Sure.
Okay. So it is recording now.
Hello, future me.
Yes.
Now when you're watching this, you have to say hi, Pastor.
Aliens, someone point to copy. Do not change the copy.
4.4.
David's like.
So, like, how far back can it pick up sound? Is there some, like, someone...
Okay, you're asking me like I've had this for more than the time you've seen me with it.
I'm expecting there was a pamphlet that maybe you read.
No,
Disappointment.
I wouldn't have read it. I would have just figured it out.
Let's do it. Can
No,
we?
no. Okay, this is lesson 4.4, trigonometric functions of any angle. Okay, so in this lesson, I'm going to, given any point, find the six, quiet down, find the 6 trig functions. We're going to have a lot of this in this lesson, okay?
So you can't just use the unit circle.
No, because these are going to be points that are not on the unit circle. So unit circle is really helpful because we often use those, but that's only when I have a circle with a radius of 1. We're going to see I'm going to have circles with a radius not equal to 1. Okay, so I'm going to show you how to do that.
It's not the unit circle, it's a circle.
Yeah. Okay, so step 1. Draw a triangle using the point. The hypotenuse is always from the origin to the point. One side is always on the x-axis. Oh. It's the pen. There's less friction. It has a kinetic. It has a smaller coefficient of friction.
Can we just stop?
No units, the symbol is mu. You knew it, yeah.
It's okay.
Let the record know that Hudson Sheets motioned with his hand the correct symbol for mu. Okay. Those of you not in physics are missing out. Okay. The y side is drawn from the point to the x-axis. Okay, so all of this makes sense depending on which quadrant we're in. Okay? So there's going to be different situations with whichever quadrant we're in. So let's draw what the situations look like. Okay?
Okay.
Let's do some color. That's fun. Okay, so if I'm in quadrant 1 and I have a point in quadrant 1, I would draw my triangle, my hypotenuse. My hypotenuse is from the point to the origin. It's pink. It'll show up pink. It's because I just drew over the black. Does it show color? It should. Okay.
Hey.
I am going
It
to
does
draw.
not this way.
Okay. Quiet down. I'm going to draw from my point down to the x-axis. And then the last side of my triangle is on the x-axis. Okay? So my theta is here. So this is when I have a point in the first quadrant.
Theta is closest to the origin.
Theta is from the x-axis up to my hypotenuse. If I have a point in quadrant 2, my hypotenuse is from the origin to the point. Bless you. I'm going to drop my y side down to the x-axis, and then my third side is here. Where is my theta? It goes around. It starts from the x-axis and comes here. Mm-hmm. Anytime we'll get there.
So you use theta as a 180 minus theta.
To get the reference angle. Okay. Okay. If I am in quadrant 3, and I have a point in quadrant 3, I am going to draw my hypotenuse. I will tell you, one of the mistakes I see people make when they draw these triangles is they try and go from the point over to the y-axis. You have to draw going to the x-axis. Okay? And then I have my third side right here.
So it comes around.
So theta always starts positive x-axis, comes around like this. If I am in the fourth quadrant, again, I draw up to the x-axis, and I draw my triangle. My theta is this. Okay? When we were dealing with the unit circle, my hypotenuse was equal to 1. So my triangle, my hypotenuse of my triangle, the radius is equal to 1, so the hypotenuse was equal to 1. Here, the hypotenuses are equal to, I'm going to say r, the radius of the circle. So I'm going to go in and put an r next to those.
So it would be like first side.
Hang tight, hang tight. Okay? In the unit circle, we have coordinates for every single of the special angles on the unit circle. We have a coordinate point for every situation, special angle. We have an x and a y. I have an x and a y on my triangles. Okay? This is my x. This is my y. This is my x. This is my y. This is my x, this is my y, this is my x, this is my y. Okay? Now, before, we would say sine theta equaled what? If I were on the unit circle, what did it equal? X. Because the radius was 1.
Wait, sine theta equals y.
No, sine theta equals y.
Sorry.
Yeah.
My bad.
So, no, sine theta equals y. I should have thought that. Sine theta equals
So I was
y.
setting you up. And
Yeah, and I fell for it. Okay? Back on track. Sine theta equals y because the radius was 1. In this case, sine theta equals y over r. Okay? On the unit circle, that's a special case where r equals 1 and sine theta simply equals y. But now we're going to do for any case where I could have any radius.
same with cosine x.
Cosine theta is equal to x over r. What about tangent theta? What is tangent? Y over x? Yes. What about,
So that doesn't change.
no. What about cosecant theta? R over y. Secant theta,
R over X.
r over x. Cotangent theta, x over y. So for tangent and cotangent, it does not matter what the radius is. Okay, but the others, it definitely does. Okay, let's look at an example. And this is example number 10. Okay, and this has two parts. For part A, I have too much of it. Okay, so for part A, this is what they have drawn. And our instructions are to find the trigonometric values of all of the 6 trigonometric functions of theta. Okay? Say that again?
Negative 12, negative 5, 6, 7, 2, 3.
Yeah, it is. Yes, negative 12, negative 5. Okay. Okay, so back to the guidelines that I drew before. Create a triangle, drawing up to the x-axis and across on the x-axis.
Wait, so can I ask you a quick question?
Yes.
So, right here, I have the theta going to the x-axis.
No,
Where
it should be
it
going. It should be going all the way to the radius.
Thank you.
You're welcome. Okay. So this negative 12, negative 5, that tells me the lengths of my legs of my triangle. Okay? So, well, the lengths are positive, but because I'm not dealing, I have to include the signs. Because the signs matter because I'm in a specific quadrant. That's very true. If I said length, length is always positive. But in this case, this is like a time where I need to include the sign so that my trig functions come out correctly. Okay? Because I'm going to use this as x equals negative 12. Not the length so much. Equals negative 12. Yes. So y is negative 5. The hypotenuse will always be positive. The radius will always be positive. 5, 12, 13 is the Pythagorean triple. Okay? So Pythagorean triple. You're going to see we don't always get Pythagorean triples, but they're nice when we get them. So 5, 12, 13, and you'll learn to recognize them. Okay, so now we have to go through with our sine theta, cosine theta, tangent theta, cosecant theta, secant theta, cotangent theta. So in this case, what does sine equal? Negative 5 over 13. What about cosine? Negative 12 over 13. Tangent. 5 over 12. Tangent is sine over cosine. cosecant? Negative 13 over 5. Secant? Negative 13 twelfths. Cotangent? Yes, 12 over 5. Okay. Part B of this problem gave me a different point, and it drew a point in the fourth quadrant, and its coordinates are 1, negative 1. And theta is obviously right here. Okay. I'm going to draw my triangle, draw up to the x-axis, and draw along the x-axis. What are my sides? Which leg is which? X equals 1, and this is negative 1. What is my hypotenuse? Square root 2.
Wait, isn't that a regular?
Hmm?
Isn't that 1-to-1
Special right hand.
This is a special right triangle. So 45, 45, 90.
Isn't that on our chart? What if this one?
Yes. Okay?
This.
Yeah. All right, we need to find sine theta, cosine theta, tangent theta.
Wait, it's on our unit circle?
Lord, she said.
Wait, how? If the radius is square root of 2. That's different than the unit circle. The unit
Yes,
circle.
it is. That's true. Is it?
Yeah.
Okay. Hang tight. Hang tight. What is sine in this case? It's y over r. So it's negative 1 over square root 2, which is negative square root 2 over 2. Cosine theta is going to be, yep, square root 2 over 2. What about tangent theta? Is what? It's going to be negative 1. What about cosecant theta? Negative square root 2. What about secant theta? Square root 2, negative 1. Are those values that are the same as a angle measure on the unit circle? Negative pi over 4 or 7 pi over 4. Okay. Okay.
How does that work with the radius?
It has to do with the fact that this the sides are 1. This is actually not on the unit circle because the radius is not 1, but the values come out to be the same.
Okay.
Okay. Okay. Example number 15. Example number 15 gives me the point negative 5, negative 2, and says the point is on the terminal side of the angle in standard position. Find all 6 trig functions. So the only difference between this and what we just did is this time they didn't draw the triangle for us. Or they didn't draw it on the set of axes for us. Right? So we need to go ahead and plot this. Negative 5, negative 2 is in what quadrant? 3. Right? So I'm here. Okay, I have -5, -2. Is that a triple? No. So I need to use Pythagorean theorem. -2 squared plus -5 squared equals, so I have 4 plus 25, and I get 29, so my radius is square root 29. Okay, I need to do sine theta, cosine theta, tangent theta, cosecant theta, secant theta, cotangent theta. Go ahead and do these at your desks. Okay, have we gotten answers? So we should have, for sine, we should have -2 square root 29 over 29. Cosine theta is -5 square root 29 over 29. Tangent theta is 2 over 5. Cosecant theta, negative square root 29 over 2. Secant, negative square root 29 over 5. And cotangent is 5 over 2. Yes.
I don't get how using the whole theta angle, like you can find sine of theta. Like, because wouldn't it be the same if theta was just inside the triangle? So how can you use the whole thing to find?
Well, if I was just using theta inside the triangle, if I were using it as just a triangle problem, my sides would not be negative.
So,
Okay, we're going to be talking about something called reference angles, and that's going to talk exactly what you're talking about. Okay, so hang tight. We're going to get there today. Okay, that's a good question. Okay. Yes. Okay. Quadrants with positive trig values. Okay, so I have my quadrants, quadrant 1, 2, 3, and 4.
Or 1 and 3, sorry.
Depends on which trig function I'm looking at. Okay. So in quadrant 1, well, let me give you the saying first. Okay. What is it? all students
Take it.
take calculus.
It's not true.
It should be. Okay? So how this works, how all students take calculus, I start in quadrant 1 and put an A. In quadrant 2 I have an S, quadrant 3 I have a T, and quadrant 4 I have a C. She's coming. Okay? The A means all trig functions are positive. So I can put all positive. The S means sine is positive. But if sine is positive, what other trig function is positive? Cosecant. Okay? So sine is positive and cosecant is positive. The T, what is the T meaning? Tangent is positive, and if tangent's positive, what other one is positive? Cotangent. The C is telling us which is positive, cosine, and if cosine is positive, secant is also positive. Okay. So then we can have problems like example number 19. And number 19 tells us sine theta is greater than 0 and cosine theta is greater than 0. Which quadrant does theta lie? Okay? So what I do when I'm doing this is I will say, okay, so let's do sine theta greater than 0. Is greater than 0. Which quadrants is sine positive? 1 and 2. So I'm going to go ahead and put an X and an X. Okay? Cosine theta greater than 0. Which quadrants is cosine theta greater than 0? 1 and 4. So let's put an X and an X. The one where they both overlap is the quadrant that they lie in. So the answer is quadrant 1. Okay, another example, this one's not in the book. Sine theta greater than 0 and tangent theta is less than 0. Okay, so let's go ahead and do sine theta greater than 0. We already said from the last problem, sine is positive greater than 0 in quadrant 1 and in quadrant 2. All students. Now it's asking where is tangent theta less than 0 or where is it negative? Well, all students take calculus. Tangent is positive in quadrant 1 and 3, so it's negative in the other two. So it's negative in quadrant 2 and 4. This is the one where I'm overlapping, where both of them lie. The answer is quadrant 2.
So, if 2 are greater than 0, you can assume it's always positive.
Say that again?
If 2 are greater than 0, you can assume it's
Yes,
always
you can always, because that's the only quadrant where all of them are positive. Yes. Okay. Find the values of the 6 trig functions with the given restraint. So this is example number 27. And number 27 gives us the following information. It says cotangent theta equals -3. And cosine theta is greater than 0. That's all it tells us. Okay? Nope, we're not going to use identities. So I know if cotangent if cotangent theta equals -3, that's the same as -3/1. Right? Exactly. And we know that cotangent theta is equal to x/y. Right? So my point is equal either -3, 1 or 3, -1. Which one is it? I need to figure out from this constraint which quadrant it is. So I know that so cosine is positive in which quadrants? All students take calculus, 1 and 4. So -3, 1 is in quadrant 2. Is that the right answer? No. 3, -1 is in quadrant 4. That has to be the one that it is. Okay? So this is the correct point to use. All right? So let's go ahead and graph it. Draw our triangle. And I know that this side is 3, this is -1. What is my radius? Square root 10. Okay, so sine theta, cosine theta, tangent theta, cosecant theta, secant theta, cotangent theta. What is sine theta equal? It's -1 over square root 10, so it's equal to negative square root 10 over 10. Cosine theta is what?
Negative.
It's not
3
negative.
square root of 10 over 10.
3 square root 10 over 10. What about tangent?
-3.
No.
And then -1 over 3.
-1 over 3. What about cosecant?
Square root of 10.
No.
No, negative square root.
Negative square root 10. What about secant? Square root 10 over 3. And cotangent? -3. Okay. Let's do another one. Let's look at example number 28. The constraints that they give me is that cosecant theta is equal to 4 and cotangent theta is less than 0. Okay, which quadrants are cotangent negative? No.
2 and 4.
2 and 4. Cotangent is going to be the same as tangent.
So 3.
No, it's 1 and
Oh, less than 0.
It's less than 0. So tangent is positive 1 and 3, so that means it's negative 2 and 4. So my options are here or here.
She's smart.
All students take calculus. Okay? Tangent is positive in 1 and in here, in quadrant 3. It's asking where cotangent, which is going to follow the same rules as tangent, where is it less than 0? Where is it negative? If it's positive here and here, it's negative here and here.
So
The reciprocals go with the sine and cosine and tangent. Okay? Okay. So cosecant theta equals 4 over 1. And that is the same as r over y. So they're either both negative or they're both positive.
R
Well, they're-
always has to be positive.
R always is positive. So that means this is 4 over 1. My point is, well, I don't know what my point is, but I know which quadrant am I in?
No.
No.
You're in one.
My y is positive.
So you're in one for sure.
No, I'm not. I said that my only two choices are 2 and 4.
So you're in 2.
I am in quadrant 2. Okay, let's go back and let me explain that again.
I got it.
We don't know what the x is. I don't know any information about the x yet. All I know is my hypotenuse is positive, but no matter what quadrant, hypotenuse is positive, because r is positive, always. The y is positive. Which quadrant of the two that I can choose from is y positive? Quadrant 2. Because in quadrant 4, my y is positive. I mean, my y is negative. X is positive, y is negative. Does that make sense? Yes?
X isn't even something we're looking at in this scenario.
Yeah, I don't know what my x is yet. I'll figure that out. Okay? So let's go ahead and draw our triangle. So I know that I am in quadrant 2. My radius is 4. My y is a positive 1. What does my x value have to be? Well, yes, it's going to be square root 15, but it has to be negative. Okay? So I have 4 squared equals 1 squared plus x squared. Or 16 equals 1 plus x squared. 15 equals x squared. When I take the square root, it's always plus or minus. So x equals plus or minus 15. If it's in quadrant 2, x's are negative. So I have to say x equals negative square root 15. Does that make sense? So the hardest part about these problems is going to be the negative. Okay, and figuring out which quadrant, which ones have to be negative. Follow the rules of the quadrants. What signs do x and y have to be in those quadrants? Okay, so now I can go ahead and do my sine theta, cosine theta, tangent theta, cosecant theta, secant theta, cotangent theta. What is sine theta going to equal? 1 over 4. What about cosine?
No, it's negative.
Negative. Negative square root 15 over 4. What about tangent? Negative square root 15 over 15. Right? Because I do sine over cosine, my denominators are gone, I have 1 over negative square root 15. And I have to rationalize. Okay? Cosecant is equal to 4. Secant
Negative 4 square root of 15 over 15.
and cotangent,
Negative square root of 15.
negative square root 15. Okay? Not that bad. Okay, back to what Ford was talking about earlier. Okay? when he was talking about, okay, so if this is theta, but we're dealing with a triangle, okay, we have something that we actually call reference angles.
Will we ever have to find like the theta outside the
Yes. Okay, hang tight. Okay.
Michael Scott when he sees
Okay, I'm only doing one lesson a day. That was my promise to y'all when we entered Trig.
About next chapter.
Next chapter will only be one lesson a day, except maybe in the beginning. I think the first lesson is like pointless almost. There's very little in it that we're going to use, or it's very short.
Watch everybody struggle.
No.
Everybody's going, this is the hardest book ever.
What chapter is
You get tear stained homework.
Chapter 5, the next one.
You're gonna get tear stained pages from everybody.
Are we going to be doing a trig for the rest of the year?
We will be doing solely trig for chapters 4, 5, and the beginning of chapter 6, and then trig is used throughout, not all the time, but it can be peppered through anywhere the rest of the year. Okay? Okay. Back on track.
Are we going to finish lesson 5 this semester?
Yes.
And then we'll start 6.
We'll start 6 next semester. Wait, no. We will not finish chapter 5 this semester.
Really?
Is that a good
No.
thing?
Is that on track? Like,
We're behind. We're behind. We're on track with where the class was last year.
okay.
I'm okay with that.
Okay.
Okay,
Yeah,
I'm not
because
concerned.
I'm looking at your professor somehow.
And we're back.
Yes, ma'am.
Hello.
Okay. Reference angle is the acute angle theta prime formed by the terminal side of theta. What does that mean?
Something really complex.
What is the
Okay. What does the prime mean? It just signifies a difference between theta and theta prime.
Yeah.
Okay? So if I'm in quadrant 1, that's the easiest one. Okay? This is theta. Theta prime is the acute angle formed by the terminal side of theta. It's the exact same angle. Okay? And if I'm in quadrant 1, the reference angle is the exact same angle as theta. If I'm in quadrant 2, this is theta. We all agree with that? The reference angle is always drawn from the terminal side to the x-axis. So this is theta prime.
That sounds like what?
What about quadrant 3? Quadrant 3, quiet. Quadrant 3, I have theta. What about theta prime? Oh, yeah, theta prime.
Is it to the other end?
180 minus.
It's going to be this. Goes the opposite way. It always goes to the x-axis.
So you can't go to the other x-axis.
Wait a minute. I take that back. I take that. It's coming back to me. Yes. I remember this last year being confused about this. The angle goes the other way.
What?
Oh wait,
Wait,
it always
doesn't
is
it?
clockwise.
Is it really?
The angle always is going,
So it's always
the,
in between
Does
the
it really
terminal side
matter
and
like
the
which way it's gonna be increasing?
it's always going counterclockwise. It's always going the same direction as theta. Okay, and let me put it that way. Not that it's going, if I'm negative, my reference angle will also be negative. Okay? It'll be going in the opposite direction. Does that make sense? So the reference angle is always drawn in the direction that theta was drawn. Does that make sense?
Oh, so if you go
Yes.
that way.
So if it's a negative.
You would.
So why wouldn't you, actually, you know what,
Mm.
the question I was gonna ask was dumb, so I'm not gonna ask it.
Okay.
Good restraint.
Moving on.
Alright. I'm glad you changed your mind.
There is no dumb question.
That's bad.
You're
There's only.
Funny.
You're welcome to ask it.
Are we there yet?
No, we're not there yet.
She wanted to smack you so hard.
No, I didn't. Okay. Okay, if I'm in quadrant 4, theta comes all the way around like this, and my reference angle is going to be drawn this way. Okay? Example number 46. Number 46 tells me that theta equals 309 degrees. It asks me to find the reference angle, find theta prime, and sketch theta and theta prime. That's not very hard, right? So if I sketch 309 degrees, what quadrant am I in? Fourth, right? So theta, okay? So theta prime, we know, is going to be here. How can I find out what theta prime equals? 360 minus 309, and that equals 51 degrees.
Would that be considered a sketch?
Yes, that's all. This is the sketch. This is what they're
The sketch
asking
in
for.
essence is helping you find it.
Yes. Yes.
That's actually really nice.
Yes.
Isn't it offensive?
Okay. Let's look at example number 53.